Hello students, your physics teacher Hassan Darwish with you. In this video, I'm going to explain the work done by a force on a rigid body in rotation. Remember, in the last two videos, I explained the work done by a constant force in the case of a rectilinear displacement and the work done by the weight of a body, which is a constant force also, on any curvilinear path. But before I do it, I prefer to review with you the rotational motion of a body around an axis, fixed axis of course, and the moment of a force acting on this body with respect to the axis of rotation. Let's start. So here in rotation, every particle of the body moves along a circle where all these circles are parallel and their centers lie on the same straight line. We call it usually delta. This line is perpendicular to the planes of the circles and is called axis of rotation, like when you open or close the door. Every point on the door will draw a circle, will describe a circle. I mean, its trajectory is a circle, every point. Where is the center of each circle? You know, the center of each circle along the vertical line joining the hinges, right? Okay. Hence, a rotation, every particle moves along through the same angle, theta, within the same time interval. Therefore, every particle has the same angular speed, theta prime, and the same angular acceleration, theta w prime, as any other particle. Okay? Good. So in rotation, all particles have the same theta prime and theta w prime. Now, moment of a force about an axis. Let me first remind you with the moment of the force. Let's consider a door movable around the vertical axis of its hinges or hinges. Here is the door, and here is delta, the line joining the hinges. Clear? Now try to open the door by applying on the handle here a vertical force F parallel to delta. In your opinion, does the door open or close? You know it's not. Now let us apply the force along the plane of the door in which F intersect delta, as you see here, F intersect delta. In your opinion, and if you try it, does the door open or close? Of course not. Now let us apply the force F as shown here in figure C, which is neither parallel to delta nor intersecting delta. Here is the F, which is the force, is called or is known as skew with delta, non-coplanar with delta. You know, in this case, the door open or close, right? Good. So in this case, We say when the door moves or rotates around the hinge, we say that F has a moment with respect to delta. Why? Because F rotates under the action of F. That's the concept of the moment of a force. When the force F is either parallel or intersecting delta, the door or any other body does not rotate. So we say F has no moment with respect to the axis delta. While when F and delta are non-coplanar, we mean skew relative to each other, the body rotates. In this case, we say that the force F has a moment with respect to delta. Okay? That's the moment, the concept of the moment of a force with respect to an axis. So F parallel to delta has no rotational effect. That's the first case. Second case, F intersect delta, as we said. So no rotational effect, so no moment. As I said, to produce a rotation of a solid about an axis, the exerted force F should be neither parallel to the axis nor passing through it. Okay? But when a force has a rotational effect on a body with respect to an axis delta, we say this force has a moment. Okay? With respect to delta. Good. Any problem? Now let's find the moment of a force with respect to delta. Here I have any body. Look at this solid body. This body can rotate around the vertical axis delta. Means this body can rotate in a plane parallel to the xy plane. I have here applied a force F at point A. Means I am pushing this body at point A to rotate like this. So every point of this body will move along the circle, okay? Like this. Now what is the moment of this force with respect to delta? Here I have made a simple figure. This is the point of application A and this is F, which is neither parallel nor intersecting delta. Here is the perpendicular distance from the axis delta to the force OH. The moment of F with respect to delta is by definition magnitude of F times the perpendicular distance. This is perpendicular distance, which is equal F times OH. And you know that force F in Newton, distance in meter. So the moment becomes Newton times meter. This is Newton and this is meter. So here Newton meter. Okay? Any problem? Now let's find the work done by this force on the body. You know that when you applied the force on the body is displaced. So there's what? There's a moment. There's a work. Consider a rigid body like this body, say, any body. Consider a rigid body in rotation around an axis delta and a force F act on the body through an angle theta. Now the work done, by definition, the work done, we accept this without proof, is by definition moment of F times the angle theta, where theta is the angle of rotation. Here it is. Okay? Now moment F times d perpendicular as I said, stands for the moment of F with respect to delta. Okay? That's the definition of the moment. We solved this example in the last video. Now let's solve an example about the work. Okay? Here we have a bolt, and we have here a key to loosen the bolt. The bolt will rotate around point O. So to loosen a bolt, a force of magnitude 200 Newton, here it is applied on the key at point A. Calculate the work done by this force for a rotation of 30 degrees. I mean, this is the angle theta. Okay? So by definition, what is the work done by the force and rotation? Work done by F and rotation, as you know, it is what? The moment of F with respect to delta, of course, times angle theta. But the moment of F is by definition F times the perpendicular, right? F times perpendicular distance times theta. We have theta 30 degrees, but we must change this theta 30 degrees into what? Into radian. You know how. 30 degrees times pi over 180, or 2 pi over 360, because each pi corresponds to 180 degrees, right? So this is pi over 6. And we have F. F is how much? 200 Newton. Okay? We are left with D. So this is time. Now what is D? D is a perpendicular distance from the axis delta to the line of force. This is point O, and here is the force. So we draw the line of this force. And then we draw perpendicular to it. Here is the right angle. Okay? Now what is the value of this angle? This is D. Don't forget. This is D. What is the value of this angle? Here we have 120. So this becomes what? 60, right? Because 120 plus 60 degree, 180. So this distance D, let's calculate it. We use the right triangle. OA, say H here. Sine 60, or D, equal this distance, which faces the angle 60, is equal the hypotenuse OA times sine 60, because sine angle equal opposite over hypotenuse. So the opposite equal hypotenuse times sine angle. Sine 60 radical 3 over 2, and OA is given how much? 30 centimeter. So this becomes 0.3. We changed centimeter into meter. 0.3, and sine 60 is radical 3 over 2 equals, I will leave the calculation for you, okay, Newton meter. That's the work done by a force in rotation. Okay, this is everything in this video. See you in the next video. Take care. Bye bye.